Hello team, welcome to my session on Coffee with Prab, and today we're going to discuss about Cryptography Fundamentals, which is symmetric and asymmetric. I made this video in such a manner the person with the basic IT can able to understand that. Who am I? My name is Prab Nair, and for more information you can refer my LinkedIn profile. If you're new to my YouTube channel, click on the subscribe button and bell icon to make sure you should not miss my future videos. Without wasting your time, let's move to the next part. Thank you. So when we're talking about cryptography, let me first explain you the basic fundamentals of cryptography. What is crypto and what is graphy? So crypto plus graphy. Let me split that. Crypto means secret. Okay. Secret mean encoded, unreadable. मुझे नहीं पता क्या होगा. So what I did, I spoken in Hindi. Now those who don't know Hindi, for them it's a secret. But those who know Hindi, they can able to understand what I said. So for the people who are not a Hindi listener, they will not able to understand. And my goal is to make sure that this information only available to the authorized user. Okay, so I spoken in a language which can only known by Hindi. So this is called as a secret text, encoded text, unreadable data. And graphy is called as a science of writing. Science of writing. That's why if you see the definition, it says science of writing data. Science of writing data into secret text is called cryptography. Now in cryptography, we have some basic terminologies. The first terminology is called as a encryption. It means it is a process itself which convert the data from plain text into the unreadable format, which is only and only available to the authorized user. As I said, this is me, which is Prab. And this is my friend whose name is Manish. My best friend, you can say like that. He's my lovable friend. So I always use this example. So what I did, this is my text we have. Okay, and now we have some set of 70 people here. They knows English only. So what I did, I convert this text, which is an English text, into Hindi. And I told Manish bhai, I'm sending you some data. Okay. And I mention in Hindi because if I pass through the 70 people, they will able to understand. So I converted into Hindi. So when you receive, you read that. So you'll get to know what I want to convey. So what I did here is I convert the English into Hindi so that only Manish can able to understand. This process is an encryption. Okay. A technique by which I convert English into Hindi. So from the information security point of view, you can say like that. It is a process by which I convert the readable data into the unreadable format so that only authorized party can able to access. In this case, Manish can only able to understand because Manish know in that group Hindi. But decryption is a reverse process where we decrypt the encrypted text or unreadable text back to the plain text. The representation of the readable value that is called as a plain text. Here the English was the plain text. And encoded value, unreadable data, that is basically called as a ciphertext. Okay. So this is the high level process or terminologies that we used in the cryptography. Now before moving ahead, let me give you very basics overview of entire element that we're going to cover. Now if you take example here, if I say cryptography, crypto plus graphy, it is actually divided into two parts. We have a modern cryptography and we have a classical cryptography. If we're talking about the modern cryptography, we have a two type of modern cryptography. One is called as a symmetric and one is called as a asymmetric. But when you're talking about the classical cryptography is basically two type. One is called as a substitution, and one is called as a transposition. Actually, classical cryptography is more like an encoding concept, and modern cryptography is more like a core encryption. Now let me explain you the thin line difference between encoding and encryption also. Now when I say encoding, this is my text we have. Example, this is my text money. This is my plain text. I use one encoding language. I convert M into B. I convert A into H. I convert N into D. And I convert I into A. Bada. So I replace character to character. That is called encoding. But in the encryption, what happens is we have a plain text called money. And that will be converted into binary. Then, so this is my plain text. Now we need a key. Key is the logic. Sorry, key is the factor. So key is like a passcode, capital P A $$ W0RD example, which will be converted into binary. Then between that we do the XOR, just giving example, and that value will be my ciphertext value. That is why encryption take more time than encoding. Encryption take more processing than encoding. So we are doing a changes in the binary level in the encryption, where in the encoding we introducing a changes in the character level. Coming back to the cryptography part, in cryptography we have a two important component. One is called as a key and one is called as an algorithm. One is called as a key and one is called as an algorithm. So key is called as a factor and algorithm is called as a logic. Let's take example 1, and logic I use plus. I'm using one base language here, which is like a alphabets. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So this is the alphabet I use. So when I use in a classical cryptography, what I did, I use key as a 1 and plus is a logic. Then I combine that, plus 1. Because algorithm is called as a logic. English I'm using as an algorithm. But what is the phrases I'm using in the English to communicate, that is called as a key. Because key is the factor. I will show you the example. Now in the substitution cryptography, what happened is, this is my plain text called, let me delete that. Okay. Now I have a plain text which is called security. Okay, this is my plain text. And now I want a encoded text. So what I did, I use a +1. Substitution means using an alternate value. So we have a S, that is S. S plus 1 is T, because S after S plus 1 is coming as a T. So I use the T as a value. E plus 1 is F. C plus 1 is D. U plus 1 is R plus 1 is S. I, we have a I. Then we have a J. Then we have a T. We have a T, U. And Y, Z. So this is basically my encoded text. If you notice, if the key length is small, it is easy to find the pattern. Now instead of +1, I use -1 example. So we have a S, S before minus R. So this will be the R. So in substitution, we're finding an alternate word. But when you're talking about transposition means trans plus position. Transparently, we're changing the position. How? S plus 1 is E. So E will be the first. E plus 1 is C. C will be the second. C plus 1 is U. U plus 1 is R. R plus 1 is I. I plus 1 is T. T plus 1 is Y. Y plus 1 is S. So this is how I use the transposition cipher. Okay, in substitution, we're finding an alternate word, but in the transposition, we're just replacing the character. So this is the high level summary of classical cryptography. But what we're going to learn in modern is a symmetric and asymmetric in my next slide. Now, when you're talking about cryptography, as I said, encryption, decryption, plain text and ciphertext, in modern cryptography, we have two major components, a very, very important, which got enhanced. One is called as a key and one is called as a cipher. Another name of the cipher is algorithm. So key is a specific piece of information that is used in a conjunction with the algorithm to perform the encryption and decryption. If you saw in my previous example, plus and 1. So plus was the algorithm and 1 was the key, which is used together to perform the encryption and decryption. I told Manish, hey Manish, A plus 1 is B. So remember, so plus is the algorithm calculation with the alphabets and 1 is basically the factor. So one simple rule you need to remember with reference to the key, longer key produce the stronger encryption. Let's take an example. My key length is 1111. So it will produce the fixed output of 111 example. But if I have a larger key plus 2, 3, 5, 6, 7. So they will see the 2, 3, 5, 6 pattern and by which they basically form the key. That's why we say larger the key or bigger the key, more secure and more stronger will be the encryption output. Now I told Manish, okay, remember plus 73. So then they will calculate the plus 73 values and then it produce the output. But problem is that bigger key, higher key, bigger key size will produce the more secure output, but it take more time also. So whenever we selecting the key for the encryption, okay, we need to balance the performance and security. That's why we call as a key is the process which is used with algorithm to encrypt and decrypt the data. And cipher is called as an algorithm. Another name of cipher is algorithm, which is used to encrypt, decrypt the data. And there is a process called science of breaking the code or learning the cryptography algorithm or finding a weakness. And that process is called as a cryptanalysis. A lot of company hire cryptanalysis whose primary role is to discover the weakness in the cryptography algorithm, study the cryptography system so they can able to break it. Now there is a possibility like me running a cryptography solutions. So what I did, I hired the cryptography professionals and I told them, find the weakness in my system, find the weakness in my algorithm. So they tried to break my algorithm. How? The data which is encrypted by the algorithm, they try to break the data. They try to recover the plain text from the data. And then they will give me the report. Okay, by this factor, we are able to break it. So we will add that information and make the algorithm more secure. So study of algorithm, process of breaking, that is called as a cryptanalysis. Moving to the next part, we're going to cover about type of cryptography, which is called symmetric and asymmetric. Let's move to the next part. Okay, so symmetric encryption and asymmetric encryption. If you go by the description, symmetric key used to encrypt and decrypt the data. Symmetric key use the same key which is used to encrypt and decrypt the data. That is called symmetric encryption. And asymmetric is basically used two-way encryption that is used with pair, public key and private key. It means one key is used to encrypt and one key used to decrypt. Okay. So how it works? Let me explain you. So let's start with the first part, which is called as a symmetric encryption. So if you read the description, it is clearly say that two-way encryption scheme in which encryption and decryption are both performed by the same key. How? Let's take an example. We have a system A and we have a system B. This is my data. So we got one key which is called as a, this is called as a symmetric key. Now we have a different name for that. We called symmetric key, we called session key, we called secret key, okay, we called private key. Okay, so we have a different name. Or in your language, you can say this is a password. You can say like that. In a very layman term, it is called as a password. So what I did, A basically use his key plus algorithm to encrypt this data and produce the ciphertext. The same example I have shown you. It is same like, you have a WinRAR document and you protect the WinRAR document with the password, right? So here the password is called as a key. Okay. So key is suppose 12798. So this is the key we have, which is used with the algorithm to encrypt the data. And this is the ciphertext we produce, which is called as unreadable data. Now A sent this data to B. Okay. It is a encrypted data which is sent to B. Now B received the encrypted data. Same like if I protect the file with my password, you will ask for the password only. Now concern here is I have to send my key, the same key. So I sent 12798. So B applied 12798 by which and plus algorithm and decrypt the data. Okay, so that is why we use 12798 to encrypt the data and to decrypt the data. That is why today's symmetric encryption is used for the data encryption. Today, if you take an example of AES, you heard about AES on your browser, wireless AES. They all are symmetric encryption only, where we're using a same key to encrypt and decrypt the data. Now there is a one concern here. The concern is if you sending the data and key in a same channel, this is called as a same channel. Now what happened? There is an attacker. He can intercept the encrypted data also, and he can intercept the key also. So by this way, he get the data also and key also. So that is why the biggest concern with symmetric encryption is the key exchange. Key exchange. And that is why they use multiple technique. One is called OOB, out of band. It means sending a key by email, sending a key in a hard disk, sending a key in a pen drive, or calling the person and dictate the key. Or the second process, they will use asymmetric process that I'm going to discuss in the next slide. So the primary concern with symmetric encryption is the key exchange. But today, primarily symmetric encryption is used for encrypting a data because it is faster in processing the data, because same key used to encrypt and decrypt the data. So when you're talking about symmetric encryption, we have a two type of symmetric encryption. One is called stream based and one is called block based. Now when I say stream based, example YouTube. Okay, so in stream based, what happened? Whatever the data we have, it is convert into binary. And whatever the key we have, okay, it is also convert into binary. So in the stream based encryption, it encrypt the digital data stream 1 bit or 1 byte at the time. It means they do like this way. So bit by bit stream is basically happen. Example, in my video, if I upload this video on YouTube and you're playing my video, okay, smoothly without any interruption, thanks to they using a stream based encryption. Okay, they encrypting bit by bit parallelly. Okay, bit by bit parallelly. Okay, bit by bit parallelly on the same time. So that is called as a stream based encryption. But when we're talking on block based, in block based, what happened? We have a data here. Data divided into block 1, block 2, and block 3. And then each block is basically encrypted by the same key. And then we send this block. Now, if YouTube is using a block-based encryption for the video streaming, so my voice will be like that. Hey guys, is that clear or not? So if you see, there's some interruptions because data was not something parallelly getting encrypted and decrypted. It is not something parallelly going bit by bit encryption. Data divided into block, and each block is basically encrypted by the keys. That is why block-based encryption used in that case when data resides somewhere in a storage. Okay. So stream-based use in application, block-based use in a hardware. So these are the two type of encryptions we have. So key exchange is a concern because same channel we are using. So we use the out of band exchange. Scalability is another challenge we have because for every user we need to have a unique keys. Example like this way. We have a system A and we have a system B, we have a system C and we have a system D. B, C, D. For every encryption we need a unique key. So imagine more and more hosts. Now B want to send data, he need to send his key. B need to send to C, he need to send to his key. So for every user, B need to issue the new keys. For every user, A need to issue the new keys to every user. So as more and more hosts increase, scalability become a concern. And we have some algorithms which support the symmetric DES, 3DES, RC4. These are the symmetric algorithms we have. Currently we're using AES, which is a replacement of the DES algorithm. The biggest reason of not using DES is it requires a lot of compute and all that. And AES, which is advanced encryption standard, they basically provide the better security and better functionality with better compute parameters. So that is the advantage we get when you go with the symmetric algorithm. AES algorithm, sorry. So I'm sure you get the understanding of symmetric. So how it works, symmetric algorithm in a real time, let me show you. Let me show you the practical demonstration of symmetric algorithm. Okay, so this is the practical demonstration. So I use this website called xcode.com. Okay, that is the name of the website we have, which I used in this reason. Now what I did, I'm going to type the message here. Hi, Prab. Okay, hi Prab. I use AES algorithm. This is the key we have that I'm using. This is the key which I'm using to encrypt the data. Let me try to perform the encryption. So this is the ciphertext we have. Okay, this is called as a ciphertext. So this is called as a ciphertext. Now what I did, I copy this and paste here. Sorry, I copy this and I paste here. Okay, now I will try to decrypt. So you can see hi Prab. So we have used the same key. We have used the same key to encrypt and decrypt the data. So I'm sure you get a visibility about symmetric encryption. So now the next part is called as a asymmetric encryption. In asymmetric, we use the pair of keys. Each pair consists of public key, which is known to others, and private key, which is only known to the owners. So that is what is called as a asymmetric encryption. So how it works, let me explain you. Now we have a system A and we have a system B. Okay, so we have a public key here. Let me draw it. So we have a public key A and we have a private key A. B also have a public key and private key. Let me draw it. So this time we have a two keys. Public key and private key. So now we have a data. So this is my data. Now A want to encrypt this data and send it to the B. So when I say public key is something which is known to other. That's what we share. And private key is basically may not be known by anyone except A. Okay, so A first request B public key, then B sent his public key. A basically apply public key of B and encrypt the data. So this is the encrypted data we have, and then A send this encrypted data to B. When B receive encrypted data, he apply his private key, and by which we decrypt the data. Now if there is an attacker, suppose if there is an attacker and he intercept from here, he intercept here also, and it intercept here, so he got the access to the encrypted data, he got the access to the public key of B. Still he cannot do anything with that because he need another portion of a key which is called as a private key, which we don't share. So one key is basically used to encrypt and one key is used to decrypt. So this is how it works. That's why we use asymmetric encryption to exchange the symmetric key. Let me give you that example also. Now we have a system A and we have a system B. As I said, we have a public key A and we have a private key A. We have a public key B and we have a private key B. We always generate a key pair, okay? Now we have a data. This is my data. What I did here, we also have one more key which is called as a session key. Another name of session key is symmetric key. So now A have a 3 keys. Always remember in cryptography fundamental, sender generate the session key. Sender generate the session key. So here A is the sender and B is the receiver. A is the source and B is the destination. So A basically use the session key and encrypt the data. So this is the encrypted data A will send to the B. A sent encrypted data to B. Now B received the encrypted data. Problem is that now B need to decrypt. So in this case B will send his public key. You know why? I will tell you why. So B sent his public key. The reason why, by this key only we decrypt the data, but A cannot send the session key over the network. So B will send his public key. A will basically apply B public key. A will apply B public key to encrypt the session key, because by end the session key is a value only. And then we encrypt and send back the encrypted session key to B. Now B received the encrypted session key. B will apply his private key to find the session key, and then session key used to decrypt the data. That is how asymmetric is used with the symmetric. So summary is that symmetric used for data encryption and asymmetric is used for the key exchange. I'm sure this point is clear to everyone. One primary advantage with symmetric is it is faster because we're using the same key to encrypt and decrypt. But one primary disadvantage with the asymmetric is that slow, because one portion of the key used to encrypt and one portion of the key used to decrypt. Let me show you the practical demonstration of asymmetric encryption. Thanks to Khan Academy, they did the amazing job. So I'm using their website reference for this practical. Another name of the asymmetric cryptography is also called as a public key cryptography, because we're using a public key to encrypt, right? So this is the website called Khan Academy. Here we are generating a key pair. Okay, key pair. So we generate the public and private key. So what I did, I copy the public key, and now I type hi prab. I click on the public key, I encrypt. So this is the ciphertext we have. Now what I did, I paste the ciphertext here. Now we have a private key here. I copy that, and we have a private key. See, I got the same message. So you can see the size and all that. Okay. So when you're talking about asymmetric, one portion of a key used to encrypt and one portion of a key used to decrypt. The biggest concern is performance and primary use for the key exchange. We have a different kind of algorithm like RSA, ECC. ECC was the alternate of RSA because it takes less compute to perform encryption. We have a Diffie-Hellman also. So asymmetric algorithms are used to encrypt the keys and symmetric algorithms are used to encrypt the bulk data. So this is what we have. When you're talking about the overall cryptography offer the confidentiality. Okay. It offer the integrity where the data has not been altered in an unauthorized manner since it was created, transmitted and stored. How? We're going to discuss in my next video. It also offers the authentication by which we verify the identity of the user or system that created the information. Authorization, those who have a key, they can able to decrypt. And by this performance, it able to achieve the non-repudiation where the sender cannot deny for his actions. So cryptography offers 5 major services. With the help of cryptography, we can able to provide the 5 major outcome of information security. So this non-repudiation, authentication, integrity, we're going to cover in my hashing topic, which I'm making soon. So this is all from my side. And if you find this video useful, do share in your network. And do let me know what is the best thing you like about this video. Another important thing, I want you to do one homework and let me know what is the thin line difference between the AES and DES and ECC versus RSA. I need your reply in my comment box. Thank you for watching my video.